Today we are going to discuss Euclid's division lemma and related problems. So first chapter, real number. Euclid's division lemma is, if given positive integers a and b, there exists a unique integers q and r satisfying a equal to bq plus r, or 0 less than or equal to r less than b. Don't confuse with this one. This statement is given like that. Already you know that if you have any number, that number here given as 7, you are going to divide by 2. You can write as 3 into 2 plus 1, or you can write 2 into 3 plus 1. Now this one is A, this one is B, this one is R. So now this 3 is quotient. That's all. So like that you can divide one number by another number. The form is definitely remainder is there, no? Already you know that how to divide one number by another number. Here we can write the remainder also. So think about that remainder. Remainder always less than the divisor. What is the divisor here? B. So here divisor B, divisor 2. So less than 2, that is 1 only, possible 1 only. Suppose the divisor 3, remainder possible 2. It may be 1, but it should be less than 3, that is 2 or 1 or 0. Suppose 550 is the remainder. That is 550 is the divisor 550. The remainder is less than 550 up to 545, 0 to 549, any number. So this is the Euclid's division lemma. By this you are going to solve some problem. Simple problems first I am going to introduce here. After that you can solve your book problems. For that, using Euclid's division lemma, find the coefficient of this number 17 and 3. Very well, you know that they are co-prime, no? 17 and 3. That definitely your coefficient is 1. They are co-prime, so coefficient 1. So now we are going to solve this one by Euclid's division lemma. So under Euclid's division lemma, how to find the solution? So anyway, you are going to divide by another number. So divisor should be less than the dividend. That is 17, 3. 3, it should be divisor. Now 17 by 3. That is 17 is greater than 3. So 17 equal to, this number we need to judge by ourselves. 3 into 1 possible, we are going to divide by 3. 3 only. 3 into suppose 2, 6 only. That number should be near to 17. So possible 2, 3, 4, 5. Like that we need to judge by ourselves. That should be nearby the number. So 3 into 5 only 15. 3 into 5 equal to 15. It should be. Suppose 3 into 6 you have 18. So here what number I want to choose? 5. Here we need to omit this one. Suppose 3 into 4, that is 12. We need to choose the nearest value, 15, no? So we need to choose 15, nearest value. So 3 into 5. So write 3 into 5. Which number should be first? That order is important. The 3 should be divisor. Don't change the order as 5 into 3. So 3 into 5, remainder plus 2. Now just you are going to divide this divisor. So write this 3 here, divide by 2. That is the remainder, divide by the remainder, 2 here. How many 2's are there in 3? Only 1 2. So that is into 1. Remainder plus 1. Once again repeat this process. So here what thing I want to write? Here we return 3, no? So like that here we need to use 2 and you need to divide by 1. So 1 into 2. So 2. So remainder 0. Up to remainder 0 you need to solve. If you have remainder 0, then the common, the repeater, no, this number is Kachisief of 17 and 3. So once again 17 equal to 3 into 5, so 15, remainder 2. Now just you need to write this number here, don't change this order. We need to write this number, no, this should be first. You can write 5 into 3 plus 2, so you are going, if you return like that it's confused one, so don't write like that. Here A, B, quotient, this one is quotient, you are going to divide your divisor B. This one is A value, this one is B value, this one is Q value, this one is R value. You are going to once again use this B value, so write this number, don't change the order. So 3 into 5, no, 5 into 3 is wrong, so 3 it's a divisor, 3. So 3 equal to, next 2 into 1, remainder 1. Next once again repeat this process. 2 here we need to divide by 1, so 1 should be right here, that 2 should be first, here 1 should be first. Like that we need to write up to 0. If you have 0, automatically the remainder is automatically the Kachisief of 17 and 3 is 1. Like that, suppose 125. 100 how many 100 in 100 how many 25? 4. So 100 equal to, it should be right the bigger number, no, 100 equal to 25 into 4 plus 0. You got 0, no, so 25 into 4, that first number, don't write as 4 into 25, don't write. If you return this 4 is the answer, like that you can choose. This is a confusion one, so always we need to write this divisor first and the quotient second plus remainder, maintain this order up to that. Similarly 455 comma 10 examples. 455 equal to, just we need to use 10, don't change that, is a bigger number, small number, like that. We need to write a 10 here. How many tens are there? 45. We know that 10 into 45 it's 450. So 445. So 450 plus remainder 5. Next we need to write this number here, no. So this number here, we need to divide the divisor only by using the remainder. So 5 should be right here. Then how many 5s are there in 10? 2 5s. So automatically remainder 0. Now the Kachisief, this repeated, no, this is the 5. Right. Next problem. 867 and 255 book problem. 867 equal to, we need to choose 3. How many 255 in 867? 2, 3, 4, like that. We need to choose, because 200, no, 200 into 3 600. 250 into 3 150, so 750, so nearby, so 3 is the possible. If you 4 means 4 into 200 is 800, so like that we need to choose this 3. So now 255 into 3, remainder we have 120. Now write this 255 here and use this 12 here. How many 102 into 45? 2, so 2 plus 51. Now once again write this 102 here, we need to write 51 here, so 51 into, so remainder definitely 0. So now Kachisief of 867 comma 255 equal to 51. So now we need to recall Kachisief of not only this, Kachisief of 102 comma 51, this number, no, also 51. Now Kachisief of 255 comma 121. Also 51. Now Kachisief of 867 comma 255, also 51. So this is the meaning, so you can got it. Now 616 comma 32. How many 616 in 32? 19. So 32 into 19, remainder 8. So repeat the process. 32 here and 8. We need to use 8. So how many 8s are there in 32? 4 8s are there. 8 into 4, 32. So Kachisief of this repeater, no, this one is 8. Right. So like that you need to solve your book problems. In that book problems, given. Use Euclid's algorithm to find the HCF of 4052 and 12576. Don't confuse this one, it's a bigger number anyway. How many 4052 are in 12576? 3 remainder. Next use this number 4052 by using 420 multiply by any number, but should be nearby, the product should be nearby this 4052. So next we need to 420, here we need to divide by 272, like that. Just do the products and we have 0 means we can cut it. Things are given now. HCF of 24, 4 is 4. HCF of 124 into 24. HCF of that things are already given in our book itself. Just go through your book and study this also. So I am given, you need to maintain this b here, b, that is important. After that this number should be left side, this number should be right side. Next these all are your numbers, right? Similarly this number left side, this number, that's the idea, shortcut, right? Next some problems. Example one, a sweet seller has 420 kaju wafers and 130, like that given. They want to arrange, and that arrangement should be maximum. What is the maximum number of things can be placed in the each stock for this purpose? So each one we need to paste, but we need to pack. It should be in a pack. What are the possible packs? What are the possible in a pack? How many numbers are possible? That is highest thing. That number should divide both number. So that is we need to find HCF. So that is, she want to stock them such a way that each stock has the same number. Same number possible. Same number means their number should divide this two number. So for that we need to find HCF. So then only we can arrange in using a least area. Right. Similarly, first problem you need to solve by using Euclid's division lemma, and the third problem also we need to solve. An army contingent of 16 members is to march against an army band of 32 members in a parade. The two groups are to march in the same number of columns. What is the maximum number of columns in which they can march? Maximum number of columns, this thing given, no? So maximum number of columns means here only 16 members, 32 members. So that's a maximum number of columns. That number should divide both things. Then only we can form a column, no? So that is HCF of these two numbers we need to find. Thank you.